Hello everyone, in this video I am going to teach you how the recurrence relations can be solved by using generating functions. Now we are going to learn the working procedure to solve the recurrence relations by using generating function. Suppose the given recurrence relation is of the form C0 an plus 2 plus C1 an plus 1 plus C2 an equals to f of n. Here C0, C1, C2 are the constants and an plus 2, an plus 1, an are the terms of the given sequence an. So this type of recurrence relations can be solved by using generating functions as follows. So now we are going to recall here, let g of x be the generating function of the sequence an whose nth term is an as a0 plus a1x plus a2x square plus and so on plus an x power n plus and so on. This is the general form of the generating function whose nth term is an. Now coming to step 1. Take summation from n equals to 0 to infinity and multiply with the x power n on both sides of the above equation number 1. Okay, then equation 1 gives like this. Summation means sigma n equals to 0 to infinity. Here the value is C0 an plus 2, C0 an plus 2 an x power n plus summation n equals to 0 to infinity C1 an plus 1 x power n plus third term is summation n equals to 0 to infinity C2 an x power n equals to summation n equals to 0 to infinity f of n x power n. Okay. Now here the second step of this procedure is express the equation number 1, equation number 2. Express the equation number 2. What is equation number 2 here? This is equation number 2. Express the equation number 2 in terms of generating functions as follows. And remember here, what is the remembrance here? G of x is the generating function of the sequence whose nth term is an. That is what we wrote here, the g of x. Okay, this is the generating function whose nth term is an. Now we have the generating functions formation. That is, in the previous video we saw the generating functions of the sequence whose nth term is an plus 1, whose nth term is an plus 2, whose nth term is an plus 3 and so on. So by using that generating function we write g of x minus a0 minus a1x by x square in place of an plus 2. Okay, an plus 2, and we write the generating function g of x minus a0 by x in place of an plus 1. Okay, and we write the generating function g of x in place of an in place of an. So equation 2 can be written as like this: c0 gx minus a0 minus a1x by x square plus c1 g of x minus a0 by x plus c2 g of x is equals to generating function. We don't know the generating function of this f of n. That's why we write as like this: generating function of summation n equals to 0 to infinity f of x into x power n. Okay. So now the third point. What is the third point in this procedure? Substitute the given values, or sometimes the given values means initial values, if any. Suppose those of the form a0, a1, a3, a2, a3 and so on like this. If any value of this form is given, then we are going to substitute in the step 2, means point number 2. Now the fourth step is, that is fourth point is, determine the value of g of x on simplification. Determine the value of g of x on simplification. And fifth step, means fifth point is, resolve g of x into partial fractions if necessary. And sixth step is, then after solving the g of x into partial fractions decomposition, then g of x may be of the form g of x is equals to a g1 of x plus b g2 of x. Here a comma b are unknown constants. So now the seventh step of this working procedure to solve recurrence relation by using generating function is g of x. We write a g of x as c1 an plus c2 bn, where g1 of x is the generating function of an, is the generating function of sequence an whose nth term is an, and g2 of x is the generating function of sequence bn whose nth term is bn. So this is the working procedure to solve the recurrence relations by using generating functions. We have 7 points here. By using these 7 points, we can solve any recurrence relation. We can solve any recurrence relations by using generating functions. Thank you.